Rakesh. Hope you enjoyed the sessions today. Basically, I'll take you through some of the Zookeeper related discussions, Zookeeper in the wild. I named the PPT Zookeeper in the wild because nowadays Zookeeper is very common in the big data environment, especially in the distributed application. Am I audible? Yeah. Especially in the distributed applications. So Zookeeper is getting used in n number of use cases. Probably I may be knowing about maybe 60% of or 70% of Zookeeper use case. It is getting used many places, and I think Yahoo has developed Zookeeper 2008, and Apache, it gone to Apache as a top level project 2009 onwards. So in these years, Hadoop community was pretty much used Zookeeper in almost all the different type of use cases. So yeah, I'm a Zookeeper committer, and there is one more component, Bookkeeper, a PMC of that component, and I love to use Hadoop stack ecosystems. How many of you are familiar with Zookeeper or using Zookeeper in your organization? So I have a couple of slides which will take you through the Zookeeper internals, and after that we'll discuss about the pitfalls when using Zookeeper. I categorize into three parts: while deploying Zookeeper, managing Zookeeper, and using the Zookeeper clients. Okay, Zookeeper is a high performance centralized coordination service, and which simplifies the implementation of many advanced patterns like leader election, like active standby, configuration store, distributed logs, queuing, coordinating the activities, and many more cases. This is the architecture of Zookeeper. Zookeeper is a distributed kind of architecture, and but only the difference is if you see another distributed architecture, it will be having like many worker nodes kind of things. But in Zookeeper, it's pretty simple. Like there will be one leader and a couple of followers which will be following the leaders and syncing up with the leader. And here, if you see all servers, everybody has a copy of the data from the leader. It will be periodically syncing up with the leader, and that will be in memory as well as a local file system. And when you start the Zookeeper servers, one of the element will be coming as a leader, and others will be following the leaders. And the main part of the Zookeeper is Zookeeper Atomic Broadcast, which will be used for syncing up the followers. And there is one more aspect, is two-phase commit. Basically, Zookeeper has adopted the Paxos. It has motivated the Paxos algorithms and developed the core part of Zookeeper. Paxos is basically, as you know, it is basically for the primary backup systems, and Zookeeper is for the state machine kind of things. And one speciality of the Zookeeper is it offers strong ordering guarantees. So whatever matters, it will deliver in the ordering fashion. Let's say I'm having 1,000 clients, and 1,000 clients are performing operations in one another way or concurrently, whatever the fashion. But all these clients will be getting the request, or getting the request will be processed in an ordered fashion. And there is no partial read or writes in the Zookeeper. Okay, one more debatable topic is Zookeeper is following eventual consistency. It is not giving a strong consistency because it is having a follower and leadership. There is a leader which can be ahead than the followers. So followers will be taking the sync up or taking the data from the leaders in eventual fashion. So it is not a strict consistency guarantees, but it delivers eventual consistency. Okay, this is a data model of Zookeeper. Like Unix file system or any other file system, it also has hierarchical namespace, and each node in the namespace is called a Z node. And Z node can have data, and there are two types of Z nodes. One is persistent and ephemeral nodes. Ephemeral node is tightly coupled with the session. Once the session dies, those ephemeral nodes will get deleted or it will get expired. And persistent node is not part of a session. It will be as long as the user deleted that nodes. And there is no rename of the Z node. Basically, all the use cases will be satisfied with creating a node and deleting and recreating like that as of now. If you have such a use case of rename, we can discuss and we can find out best way. And there is a watcher concept in the Zookeeper. Basically, the watcher is one of the important feature in the Zookeeper. If you see any recipes like distributed logs, distributed queues, any recipes, if you see, watcher is playing one of the key role, and using the watch notifications, user can play with Zookeeper, or they can write their own recipes. And you can add or remove the watchers. Usually watchers are like one-time watch notifications. Once you register the watch, and let's say data watcher or particular child watcher. For example, data watcher is bounded with a node saying that, okay, if somebody updating the data on that particular node, I am expecting a notification. So once I registered a watcher to a Z node and somebody else modified that data, that data watch notifications will fire to me. And after that it is no more. It's like a one-time trigger. You have to re-register the watch again and again if you are interested in multiple notifications. This guy, I think. You don't have inside reading points. There is no animation. Heading part is, yeah, sorry. So the recommended client libraries are Java and C client libraries. Those are built in with the Zookeeper things. But nowadays, Curator is one of the interesting project that is an incubating project in the Apache community, and they are giving Java libraries as well as all the recipes, like popular recipes like distributed queues, logs, ready-made libraries will be available. So no need to reinvent those recipes. You can directly using this Curator libraries, and Kazoo is for Python. Let's say whoever is interested in Python interface, they can go with Kazoo. These two are popular libraries. Okay, I kept this slide because Zookeeper, I am pretty comfortable with the Hadoop stack, so I didn't capture any Spark. I think Spark also using Zookeeper for the standby master. I read in the Spark. Truly, I didn't go into the Spark code base. So I'm pretty comfortable with Hadoop. So if you see Zookeeper, Zookeeper is using in most of the Hadoop components basically for the standby lead elections, active standby lead elections in HDFS, Zookeeper, Yarn, HBase, I think in different HBase also I think is using. So that is one use case. Another use case is coordinating the activities. Let's say replication factors. Let's say one of the entity regions and server goes down, it will be re-replicating with other region servers. That is one of the use case of HBase. So HBase is also using for coordinating the activities. Say there should not be multiple entities which will be re-replicating the things together, right? That will be concurrent. To avoid that kind of situations, they are using Zookeeper, making use of the Zookeeper service in such a fashion to avoid that kind of concurrency issues. And Yarn is also using Zookeeper. So, and collocations are private things. Okay, we move to. Okay. Now, when you start using Zookeeper, you will be having a couple of questions like how to use maybe the pain points or whatever people code, how to deploy efficiently Zookeeper server, manage, and using the Zookeeper client in a better way.
I have one question.
Yeah, sure.
So when you say that watch is just a one-time trigger, right? So let's say that under a particular G node, I want to know all the child nodes which are getting created. So now I get a watch, right? But my job is like I need to know every child node is getting created under a particular G node, right? So that means immediately after getting the watch, then I have to register again.
Yes, you have to re-register.
But in between, there is any child node which is getting created, then I will not be able to.
Okay, that is actually interesting thing. Anyway, you are interested on the child notifications, right? So you can write, if you use Curator, I think they are having retry mechanisms. But in your case, what you can do is for consistency, you will get a notification, right? One-time notification. Again, you can do a re-registration, right? You will be your client code in such a way that you will be getting a notification and you will be re-registering the watch, right? So re-register is nothing but you are calling a get children API. Okay, there is a get children API which will take argument as watcher or object, watcher object. So you will be calling a get children again.
Okay.
Okay, you got it right. Let's say I'm having 99.
Basically, it's like you register and then you get the children.
Yeah. Basically, you are yes. Basically, as a client, you are getting the latest data plus in register a watcher to the server side. So basically, basically it's like how to write your client code in such a way to make your things consistent.
Excuse me, one more.
Yeah.
I think the size of Gnode is not more than 1 MB, right? Or
Yes, yes.
not more than 10 MB in fact.
No, it is in 1 MB.
1 MB. I mean, why is that restriction kept in Zookeeper? I mean,
Okay, I have one slide at the maybe at the end. I will discuss. I will keep that going. Okay, and okay, I selected some of the cases. There are a couple of cases spread across in the community, but I have taken some of the cases. So we'll discuss these things if time permits. Okay, deployment case we'll see. Okay, deployment. This is one primary things. When you start deploying the Zookeeper servers, the ideal number of servers, there is an equation formed like 2n plus 1 nodes. N is the tolerated number of failures. For example, n is 1. You are tolerating 1 failures, right? So your total number of servers should be 2n plus 1, 3 servers. Out of 3, basically one more thumb rule of Zookeeper is Zookeeper works in majority aspects. Basically, whatever the operation you are performing, whatever the write operation especially, write operation you are performing, it should hit a quorum number of servers. There are two terms. One is ensemble. Ensemble is the configurable number of Zookeeper servers. Another thing is the quorum, which will be the majority aspects or majority factors will be based on the quorum number of Zookeeper Z nodes. So Zookeeper servers. So if you want to tolerate 1 out of 3, what would be the majority? 2, right? Out of 5, the majority is 3. So based on that, we can say 2n plus 1 number of nodes will give you n number of tolerated failures. Out of 5, you can tolerate 2, right? So in that aspect, 2n plus 1 is the recommended value. Okay. Next thing is when you start thinking about Zookeeper, Zookeeper is a very sensitive service, and Zookeeper is one of the maybe that point I'll discuss. One of the thing is it should be a low latency operations. Whatever the operations you are performing, it should complete within millisecond or microseconds. That is the expectation from the users or maybe the other applications. So in that perspective, if you see the Hadoop has worker nodes like data nodes, region servers, node manager like that. So usually administrator will think that, okay, why can't I put my Zookeeper into that machine? There is no problem, right? It will work. But these processes are like very IO intensive process. Something like they'll consume more disk seeks time, or maybe disk usage will be more, network usage will be more, or CPU usage will be more. But when it comes to Zookeeper, if you are not getting enough resources for the Zookeeper service will start throwing exceptions like connection loss exceptions, different type of maybe end of stream exceptions. These are the hell lot of number of socket exceptions you'll be getting, because one of the primary reason for all those things are the Zookeeper is not getting enough resource to satisfy his service. Basically the proposing algorithms, leader follower communications, those kind of things requires enough number of memory, maybe the network bandwidth should be sufficient. So that is one of the reason for the Zookeeper. We are recommending that you should not co-locate Zookeeper with a data or IO intensive processes, and data log directory like any distributed application. Zookeeper also has write-ahead logs for keeping track of the transactions. So that should not have any discontention while performing the
So let us say the data node is using Zookeeper for master selection, right?
Data node is not using Zookeeper. Name node is using.
Okay. So it means they don't have to make a network call in order to get it, because normally we co-locate so that we don't have that network.
Yeah, basically name node should be running in a very high efficient machine, right? High-end machine. Usually that is but data node you can run in any of the dumb machines, because it doesn't matter. You are having hundreds or thousands of data nodes in a cluster, but name node should be always highly available, right? In the same way, Zookeeper service also should be highly available, because Zookeeper is the one who is making the name node highly available, right? So in that perspective, Zookeeper should be running in a very high efficient machine. In the sense, Zookeeper should have the enough resource to perform his operations. When you start co-locating with some dumb machines like data node or region server, because they are heavily maybe the worker oriented operations, right? So they'll be consuming more CPU, disk, network, everything. So the ideal deployment recommendation is you should respect Zookeeper service in such a way that it should get enough resources. Otherwise, you will be ending up with something like connection loss exceptions, end of stream exceptions, many socket exceptions. Yeah.
Since name node is deployed in the high-end machine, actually Zookeeper running in the same node will be.
Yeah, basically you can have a dedicated disk. You can mount your log directed disk to a dedicated disk, and basically network obviously will be high bandwidth. And other thing is the RAM, right? Basically, when you configure the JVM heap size of the Zookeeper, you can give some priority to the Zookeeper service. So ideal expectation is there should not be any page swapping. If you have page swapping, you will end up with something like I/O operations, right? So it will degrade the performance of the Zookeeper. Let's say assume your leader is a slow machine, so gradually everybody else will be a slow, right? So now ideal deployment, what I've seen is there will be only one Zookeeper server cluster, and which will be getting used by HDFS, HBase, Yarn, like that. And maybe if your company has some other applications like Kafka or Redis or whatever. So another thing is there are different types of server roles available in the Zookeeper. So one of the criteria you can give to choosing a right server role. Okay, why I told this, there are two categories of members. One is voting members and another one is non-voting members. Voting members, what they'll do is they'll participate in voting, or let's say if the leader goes down, they'll all the followers, basically the voting members are followers, they'll join together and they'll form a new leader. So basically when you say voting members, they together performing the quorum activities, majority factors activities, and supporting the right operations. So non-voting members are like, they are just hearing the result of votes. What I told is, let's say when you perform a right operations, you have to take a decision that okay, I need to commit the operation, right? Basically that committing operations happening based on the votes, like in any normal majority things. Out of 3, 2 votes I should have for committing the operation. So all the followers are kind of voting members, participate in the proposing algorithm, and there is one special type of server is observer. Observer is nothing but he'll be just silent, keep quiet, and he'll just listen the result of the votes. So let's say if some operation is happening, one guy has created a node saying Huwaei. So observer, what it does is it will not participate in the node creation of Huwaei, but what it does is it will hear the result from the leader saying that okay, Huwaei node has been created. So it will read the data from the leader. Basically, in the next slide it will give some more data. Okay, one typical use case is data center bridge. Let's say if you have a Zookeepers spread across multiple data centers, obviously the inter data center link will be more, right? Latency will be high. So let's say I am having 2 servers running in data center A and 1 server running in data center B. In that case, leader will be communicating with the followers and followers will be communicating with the leader, right? So the latency between one of the follower and leader is high. In that case, the performance of the leader or the entire ensemble will degrade. So to avoid that kind of situation, you can decide that okay, one data center will run only quorum number of Zookeepers, another will be running observers. So the basic idea of scaling up or multiple data centers is I wanted to serve my clients quickly, right? So I am having 2 data centers, and who are connected to that data center, they have to get the data very fast. So in that case, that observers will satisfy that kind of use cases. Okay. One other thing is management. When managing the Zookeeper servers, there are a couple of use cases like I want to scale, I want to add one new server, I want to replace one of the server machine because that is slow or a dirty machine, or I want to modify the address, port, those kind of situations. So what normally happens is you have to make the entire server down and you have to make it up, because all these are like configurations into the Zookeeper prior to 3.5 version. And in 3.5 version, this new feature has come, so you can dynamically add a new server, so that no need to make the entire service down. If Zookeeper service is down, let's say I am having a name node in my system, so name node will go to a standby mode. So gradually standby name node will not serve any client operations, right? So basically the Zookeeper service should be highly available in order to make your complete ecosystem in a good fashion. So you can use this, you can explore 1.107 Jira issues. So you can find out, okay, what are all the mechanisms, maybe the discussion threads, the thought process, you can understand the tools. Yeah. Okay, another funny thing is, usually people will think that, okay, Zookeeper is like highly available things, so it will auto heal the things. Let's say if some of the packet drops, or usually many discussions I gone through in the community and from Edge-based communities. So what they'll tell is, okay, some of the packet drops, I am missing watch notifications, I am missing some of the node updations. Those kind of many issues we had come across. Finally, when we analyzing, we reached a conclusion that there are packet drops in the network or packet corruption, those kind of things. So generally, you have to be very careful about, okay, Zookeeper is like a Java process, or a process which can get affected by the operating system issues like kernel panics on the process or dropped packets, those kind of aspects. Also hardware issues. Even though Zookeeper is having the highly available using the quorum number of servers, but you have to consider these aspects. Okay, this is the last section, Zookeeper client. Okay, here basically, okay, this is one algorithm which, okay, head effect. I'll take you through this head effect. This algorithm is basically for the distributed log recipe. Distributed log recipe in the sense there should not be two multiple actors on a particular thing, right? There comes the distributed log mechanism. So the usual pattern is client who created the Z node with least number. That is one. I can define distributed log in multiple fashions. This is one way I have designed. And in this case, what I'll do is, let's say there are 100, n is 100, so there are 100 clients. So whenever the 100 client comes and asks for a log, what Zookeeper does is it will create 100 Z nodes in a sequential fashion. That sequencing will take care by the server. There is a mechanism of the Zookeeper ephemeral sequential node you can create. So there are 100 sequential node will be created at the Zookeeper server side. And one second step is, okay, I have to give a chance to one of the thing, right? So what I'll do is, my algorithm is whoever has the least number will get the log. So what I'll do is log 001 will get the log. So once log 1 is done, log 2 should know about the completeness of log 1, right? How I'll do is I'll have a watch notifications. I'll register a watch to log 1 saying that, okay, once you have done, you just notify me. So I'll maybe doing some activities, right? So what I'll do is I'll all 99 clients will register a watch to log 1, right? So once log 1 is done, all 99 will get a notification. Now basically this notification is in the sense that it will be going through the networks, right? So your network traffic will unnecessarily it will increase. But you know that, okay, next chance obviously goes to log 2, right? This is like a wrong pattern you have written in your client application. So what you can do is better second approach, in the sense 01, once it is done, it will notify 02. Once 02 is done, it will notify 03, like that. So I'll register the watches in such a way that log 2 will register watch to log 1, log 3 will register to log 2, 4, like that. So log n minus 1 will register to log n minus 2. In that fashion, I'll write. So in that case, the advantage is the network traffic will be low, right? So basically, the intention of this slide is you have to be more careful when you write your client applications. Both the things will work, but one will have the additional overhead of network traffic, right? So, okay, this is the question what he asked, that 1 MB issue, right? So Zookeeper is basically designed for very high performance, low latency operations. So what happened is this, let's say if you configure 1 GB as a data size, it will flood over the network. So you will not complete your operations in a millisecond or in microsecond. If you see the Zookeeper performance, I remember 1K operations in a second or something like that. That is what 1K operations, write operations and read operations in a single second. So if you have more data with Zookeeper, this data has to be spread across all the followers and leaders, so that network overhead will be more, right? That is one thing. And second thing is you have to flush things to the disk, 1 GB data. So basically Zookeeper is, if you have such a kind of use case, you should not go for Zookeeper. You can go for maybe HBase. Zookeeper is not meant for a data storage basically. It's meant for a configuration store, a metadata store. You can imagine like that. If you have such a use case, you can go with HBase or HDFS even. So you can dump complete data into HDFS in a consistently or reliable manner, right? So basically Zookeeper is meant for a very high sensitive data, something like configuration store, metadata store. One such thing is, let's say if you have 1 MB restriction, let's say if you're having millions of records, under one node you will not be able to store more than 10,000. If you have 100 bytes for one single name, one node name, like this ledger slash, say it is under ledger I am keeping all this data, right? I am not storing in a hierarchical way. So in this case, 001 will come here, 00 also will come here, 2 will come here, 3 will come here, like that. Under one node, all the Z nodes will be created. In that case, you should not go beyond 10,000 nodes. So in that case, you can go for a hierarchical fashion. In Yarn, actually, there is one interesting, I'm not remembering the Jira ID, probably you can search. There is one interesting discussion when that application master starts. They'll be registering the details, they'll be adding the details, not application master, the application starts, they'll be adding the details to Zookeeper, right? So in that case, they're adding under one single root, one single node. So after 10,000 nodes, or maybe after 1 MB limit crosses, it will not allow to add. It will get exceptions from the Zookeeper side. So you can do in a multiple fashion, like you can have a hierarchical structure and you can store a number of Bookkeeper users successfully using this one and it's storing this number of ledgers. Basically you have to design, you have to think twice before start using the Zookeeper, what are the limitations or something like that. Basically the getChildren API will throw exceptions. If you have more than 10,000 elements, you will ask getChildren, right? At that time it will cross 1 MB size. Total overall the character size will increase 1 MB, so it will throw exception. Basically the Zookeeper protocol is designed such a way that it should not, packet size should not go beyond 1 MB. Yeah, this is the last one. I think I took a lot of time. So basically it is high latency with many writes. Okay, this is one of the interesting things. Like Zookeeper is actually not meant for heavy write operations. If you perform write operations, what happens is it will communicate with all the followers, that consensus algorithm it will happen, and it will over usage, the network usage will be more heavy and your disk usage will be more. So basically Zookeeper is not meant for a heavy write operations. It is actually meant for maybe have written some configuration. For example, one example I can give you is I have a system which should keep all the configurations. So when next time whenever I am upgrading, I will reconfigure the things, right? So it is like use case is very less usage. I have written all the configuration to Zookeeper. Now maybe the next upgradation time only I will change the configurations of the Zookeeper, right? So or maybe active standby. Once active started running, it will continue for maybe long time. After some time, maybe the active went down, standby will be coming back. So the usage of Zookeeper in all these cases it will be less. It is not like very heavy write sensitive operations. It will be writing and it is expecting the watch notifications. So you have to be very careful that if you want a low latency, high performance Zookeeper service, you should look into your use case. Whether you are having more write operations, if you have write operations, you have to tune your topology in such a way to get satisfied. Okay. The last thing is this one, some of the points, deployment, manage and using the client. So if you have any questions, I'll take it. Right. So I have one more things. Maybe these are the companies, maybe or the projects which are using Zookeeper, and we have a good community in Zookeeper. Next slide. And these are some of the maybe the messages happening in the Zookeeper. Probably you can think about contributing back to the community, Zookeeper community, and understand what happens in Zookeeper. Okay, thank you.
Thank you guys. We have some pizza in the back.
Yeah.